Chapter 1. Introduction to Mercury. Whenever Mercury is mentioned, most people imagine a burning hot planet engulfed in flames due to its proximity to the Sun. However, contrary to this, Mercury is quite cool and even contains ice. In fact, containing ice is not the strangest thing about this planet. Hello everyone and welcome back to the channel with no viewers, and today we will continue the outer space story series, the story of Mercury, as one of the planets that can be discovered by the naked eye. No one can say for sure when and by whom Mercury was discovered. We only know that when looking up at the sky, we will see a small planet near the Sun that moves at a terrifying speed. Perhaps it is also for this reason that Mercury was named after the messenger god in Roman mythology, as the embodiment of speed. Mercury is also quite modest in appearance, as the smallest planet in the entire solar system. Mercury is only slightly larger than the Moon, with a radius of 2,439.7 kilometers. In addition, Mercury is also one of the 4 terrestrial planets in the solar system, so its structure is also quite interesting. Containing 70% metal, the rest being silicate material, Mercury has the properties of a planet tending towards instability. Unlike Earth, where the metal core accounts for just over 50% of the planet's mass, Mercury has a highly imbalanced ratio of metal to crust. Over time, as the metal core cools, Mercury will contract. In fact, according to observations from artificial satellites, from its birth until now, Mercury's radius has contracted by about 18 to 20 kilometers, a feature that perhaps no sibling planet has. Chapter 2. Mercury's unique orbit and rotation. In addition, with weak gravity at only 3.7 m/s², Mercury does not have enough power to maintain a stable atmosphere. In fact, Mercury has a special exosphere atmosphere layer. This is the gaseous layer in direct contact with outer space. On Earth we have the convection, troposphere, stratosphere, and thermosphere layers. Before reaching the outermost exosphere layer, it can be seen that with only one atmospheric layer, Mercury does not have the capacity to support life. And this exosphere is also often eroded by solar wind. So bringing life here is unrealistic. But that's not all. The surprising things have only just begun, because it is located closest to the Sun. The way the Sun passes through Mercury's sky is also unique, because on this planet, the Sun can go backwards, like all other planets in the solar system. Mercury's orbit is also an ellipse. However, Mercury has the most eccentric orbit of all. At the closest distance, Mercury is only 46 million km from the Sun, while at the farthest, it is almost double at 70 million kilometers. This orbit was created by the Sun's gravity with Mercury. When the planet is far away, gravity pulls it closer to the Sun, causing it to accelerate as it approaches the star. When already close to the star, it will be flung far away at high speed, causing it to return to its orbit at a greater distance. You can directly observe this phenomenon when throwing a sponge into a whirlpool. It will not fall directly into the vortex, but will move very quickly to the foot of the vortex, before being flung out before returning to the foot of the vortex. Thanks to this orbit, combined with its ability to rotate around its own axis, the day and year of Mercury provide a unique experience. If we define a day as the time from sunrise to sunset, or in other words a solar day, then a Mercury day lasts 176 Earth days. But with its own spin speed, Mercury takes 59 days to complete one full rotation. Meanwhile, it takes 88 days to complete one revolution around the Sun. So, putting the 3 data above into Mercury's overly narrow orbit, we get one of the most unique day-night cycles in the solar system. If we lived on Mercury, a Mercury solar day would last nearly 2 Earth years. Initially the Sun would rise very quickly, but would slow down as it approached day 45 on Earth. Then the Sun would stop in the sky as the planet's movement speed increases. After that, the planet's movement speed exceeds its rotation speed, making the Sun appear to move backwards in the sky. Finally, when the planet passes through the acceleration zone, the planet's movement speed slows down again, and the Sun continues to move across the sky, leading to night. Hearing about the day-night cycle on this planet, many people would probably want to live here and experience it. However, this is not easy. Even if one could survive on Mercury, the journey there is by no means simple. Although it is a visible planet, Mercury is not easy to observe, due to its proximity to the Sun. The only times to observe Mercury can be dusk or dawn, when sunlight is gentle enough not to overwhelm Mercury. Of course, astronomers can observe Mercury with a telescope, but this is also an issue as looking too close to the Sun can damage the lens. For this reason, the only real way to study Mercury is to send a satellite into its orbit. Sending satellites into the orbits of other planets for study has been done extensively by NASA. In the past, we have sent satellites to the Moon, Saturn, Jupiter, and even distant planets like Uranus, Neptune, and Pluto, with the 2006 New Horizons mission. One might think that sending a satellite to Mercury would be the first thing we would do, if possible. However, the opposite happened. We seemed to ignore this planet, no matter how close it was to us. Why is this so? Why was Mercury given the cold shoulder? Chapter 3. First missions to Mercury. Sending a satellite close to the Sun is one of the simplest yet extremely difficult challenges to overcome. Due to the Sun's enormous gravity, satellites can hardly fall into the gravitational field of this tiny planet. Approaching Mercury itself is not difficult. However, catching up with Mercury due to the planet's orbital speed is extremely labor-intensive. The spacecraft needs enough fuel to maneuver in space, bringing the satellite closer to the planet in order to enter its orbit, not to mention the enormous pull from the Sun. Additionally, the high temperatures near the Sun can easily defeat the circuit boards of the satellite. It was not until the 1970s that astronomers had the opportunity and conditions to try their hand at Mercury, and that was the brief flight of the Mariner 10 satellite. Mariner 10's expedition brought back maps containing 40 to 45% of Mercury's surface and many accompanying images and other research on Venus. However, after that, there were no other flights for 4 decades. In order to steer the satellite close to the Sun, it needs enough fuel, but too much fuel means it cannot escape into outer space. Being close to the Sun means excessive heat. The satellite is easily affected and creates costly incidents. Meanwhile, sending the spacecraft into outer space is extremely expensive in terms of manpower and finances. So, astronomers prioritized other projects, and so Mercury fell into oblivion, a planet left out in the cold. However, this is not the end for this planet. In 1985, Chen Wen-yen, a NASA engineer, came up with the idea of an extraordinary journey. Instead of sending the spacecraft directly from Earth to Mercury with a few gravitational boosts, we would let the spacecraft orbit the Sun 15 times. With that number of loops, it would have enough thrust to be able to catch up with Mercury and enter the planet's orbit. For the issue of the Sun's heat, engineers easily handled it with a ceramic shell, helping the ship withstand heat more easily. And so the journey to reconnect with Mercury began. The Messenger plan was launched. Messenger stands for Mercury surface, space environment, geochemistry, and ranging, meaning Mercury's surface, space environment, geochemistry and range. However, this was a name chosen to remind of the messenger god in Roman mythology. After launching Messenger into space on August 3, 2004, astronomers anxiously awaited each day to see the information the satellite sent back. The first thing Messenger did was test its tools on Earth and the Moon itself. In 2006, Messenger approached Venus and re-emerged at this planet in 2007, together studying the surface of the brightest night planet in more detail. Finally, On January 14, 2008, Messenger approached Mercury and began its research process. During this time, Messenger orbited Mercury with a huge elliptical orbit in order to avoid the planet's heat while studying and photographing the Messenger God's surface. After over 4 years of operation, Messenger provided a lot of valuable data and over 100,000 images of Mercury. One of the biggest discoveries was the huge ice mass in the northern polar region, where the sun does not shine. From the information obtained from Messenger, astronomers realized Mercury was not as hot as they thought. During the day, due to its proximity to the sun, the sun's rays scorched the planet's surface up to 430 C. However, at night, the temperature drops extremely low. In the heart of meteorite craters in the planet's two poles, it can drop to minus 180 Celsius. Thanks to this, water pits could freeze over. In addition, Mercury's surface also has a lot of impact craters, quite similar to the moon of the Earth. However, the big difference lies in the cracks stretching thousands of km. These cracks are the result of the planet's shrinking process. Through Messenger sensors, astronomers were able to learn more about Mercury's atmosphere, and knew that this planet also had a temporarily stable magnetic field. However, this magnetic field is too weak to protect it from solar wind, so ultimately, this remains a dead planet. After the giant journey, Messenger brought back a panoramic picture of the planet closest to the Sun. This was truly a journey that exceeded all astronomers' expectations. We not only know where Mercury came from, what it consists of, what its surface is like, what kind of atmosphere it has, but also understand the planet's shrinking mechanism over time. However, all good things must come to an end. After over a decade in space, on April 30, 2015, Messenger breathed its last breath on Mercury, ending its wondrous journey. Following in the Messenger's mission, on July 6, 2017, scientists at the European Space Agency (ESA) and Japan launched the Bepi-Colombo spacecraft and prepared for its over 7-year journey in the future round this small planet. The spacecraft has an unusual design, consisting of a bulging section containing two small spacecraft, one from Europe and one from Japan. These two ships will separate from the mothership when they reach Mercury and fly into different but complementary orbits around Mercury. ESA said Bepi-Colombo will follow the very strange results that the Messenger spacecraft discovered, from which to explore the mysteries on Mercury in more depth. The $750 million Bepi-Colombo spacecraft was launched on October 20, 2018 by an Ariane 5 rocket. On October 2, 2021, the first black and white images showing a portion of Mercury's northern hemisphere were released, including dozens of huge impact crater mouths and the vast Sithu Planitia plains that were once sunk in volcanic lava billions of years ago. According to the plan, from this point on, the Bepi-Colombo spacecraft will have 4 more approaches to Mercury. On 6 2023, 9 2024, 12 2024, and 1 2025, before it enters orbit around the planet on the 5th of December 2025. Mercury's future remains open. Unlike many other planets in the solar system, this is just the beginning of humanity's journey to understand its little neighborhood. And that was the story of Mercury, the planet closest to the Sun. Hopefully through this video, have a more concrete view of this planet that seems hot but cold, seems small but extraordinary. If you like content like this, don't forget to like, subscribe to us, and click the notification bell so you don't miss any videos in the future. And thank you everyone for watching, and see you in the next episode of Outer Space Stories. Peace.